Yeah, okay. So, very good evening, good afternoon, and good morning to all. I, Dr. Pallavi Saxena, SSC member of iLEAPS, and Dr. Samina, iLEAPS IPO, welcomes you all on the occasion of our third talk in iLEAPS Global Colloquium Series, Episode 4. So, with an awesome response received from the audience as well as from the speakers and, of course, scientific community, we have started this Colloquium in 2022 with the episode 1, and with the very good response received from the scientific community, we are continuing as episode 4 also in 2025. So before we move into detail, let me talk something brief about what the iLEAPS is. So iLEAPS is integrated land ecosystem atmosphere processes system, and it is a global research project of future Earth. It provides an understanding of how interacting physical, chemical, and biological processes transport and transform energy and matter through the land atmosphere interface. So, the prime purpose of this colloquium is to introduce the scientific community with the distinguished and significant work of the eminent scientists all over the world. It is a very bright opportunity for all, especially for early career researchers, to interact with the speaker and establish the bridge between the ideas and knowledge through them. So, in this episode, our third speaker is Professor Kamna Sachdeva from Department of Sustainability Sciences, Delhi Skill and Entrepreneurship University, New Delhi, India. She is the Dean and Professor of Faculty of Converging Technology and Scientific Skills at DSEU, Government of NCT Delhi. She also heads Department of Sustainability Sciences at Delhi Skills and Entrepreneurship University. She earned her doctoral degree from the School of Environmental Sciences at Jawaharlal Nehru University in New Delhi in 2008. With 16 years experience in teaching and research, she has also supervised multiple PhD scholars. She is actively involved in many projects where she works in cross-cutting disciplines to provide sustainable solutions to the environment and climate problems. Her contributions to atmospheric sciences were recognized early in her career when she received the Department of Science and Technology Young Scientist Award in 2009. Professor Sachdeva has a strong record of publications, including research papers and book chapters that focus on the intersection of science and policy. Her work and achievements have been highlighted in UNESCO's publication A Braided River, Universe of Indian Women in Science, underscoring her impact in the scientific community. So today she will talk about the science-based policy making for climate change and sustainability, where her talk explores about the gender-specific strategies, climate adaptation that acknowledge the varying vulnerabilities and adaptive capacities. So this talk also aims to promote the effective and inclusive climate action. So more would be more clear from her talk. So I again welcome Professor Sachdeva to deliver this talk. Professor Sachdeva, now the floor is all yours.
Thank you, Dr. Pallavi Saxena, for a wonderful introduction. Thank you, iLEAP, for inviting me for this lecture, and I'm honored. And this is a very good forum to interact with global researchers working in the same field where I am working and other people. So I always expect that the lectures are kind of mutual learning platforms, and whatever I know I can discuss, but definitely during the question sessions I may get good, reciprocating questions, which gives me more ideas to research further. So thank you, Team iLEAPS, for inviting me. So I'm just sharing my screen where I for the for proceeding for the lecture. Yeah. Give me 1 minute here. Okay. So I hope the screen is visible to everyone. So I am starting my lecture, and this lecture I have prepared from my own research. I'm discussing two cases in this lecture, which are actually my own research. And in the outset, I would like to thank my PhD scholars because this is a joint work which we have done together. So the first work is with Ms. Rupam, and the second work is with Mr. Divyansh, and they are my PhD scholars. So I have put up the cases from their studies, and you can say our studies, and so that I can explain what is science-based policy making and how we have used it in climate change and sustainability domain, and how we have used it to improve the policy and governance issues, specifically in India. Both the cases are from India. The first case is from Uttarakhand, and the second case is from Delhi. So briefly, first we understand that science-based policy making and climate change, and especially for sustainability, why it is important. And second important thing is that you call it a evidence-based policy making or science-based policy making. They are actually synonym to each other, and this is very important area. When we talk about science, then we talk about data, models, uh, statistics, and other tools. But how you bring it to the public, actually science-based policy making, you can call it a science and society linkages also. So you are making policy for the people who are actually bearing the brunt of climate change or other areas, environmental degradation. So bringing your research to the people is basically a main idea in this thing, right? So first of all, I kept this table for the audience, and this table is basically, I would like to show that what is the challenges. So what is the challenges we in this domain we have? So policy implementation and challenges across this domain is important to discuss first. Then only we can say why this is a need to have evidence-based policy making. So first thing is this, I have taken example from different sectors. Uh, COVID, which we have faced recently, is one very important example where we need lot of society-based decisions to be made. In that, we need scientific data, which is epidemiological data, cohort studies, data vaccination trials, and we need to speed up those data sets to do, and these studies we need to finish very quickly. So rapid decision making was required, and plus that, public trust. So whenever we provide the scientific data based policies, then trust is a very big issue, especially when we were working in the health sector. So what we have done in our study, we have done one study in health sector also. That was for Rajasthan women, basically. In that particular study, what we have done, we have found one report where we find that the upper respiratory diseases cases, COPD cases, were higher in the female as compared to male who were involved in mining work. We were very strange to see this result, and or some official report said that women cases are higher. So we tried to explore that through epidemiological studies, cohort studies, and then we came to know that what was the reason behind that. It was basically the dirty cooking or kitchens where they use biomass based cooking. So that kind of study we have established, and then we have submitted the report to the government, and later on we have linked our study with the Ujjwala scheme of Rajasthan, and the rapid distribution in that particular district for the this LPG has, uh, done, and we have submitted one policy paper to the government there, that why Ujjwala scheme is so successful and why that is important for Rajasthan like state. So this is also one of the policy we have worked for, using scientific data sets. And our research just started from one environmental report which mentioned that the COPD cases in female are higher than the male in a Karauli region of the Rajasthan. That is the only starting point, and then we did a lot of cohort and epidemiological studies, and then we came to the policy decision, and we proved that Ujjwala scheme is very successful, and it is going to help the public health, affect the public health in that area. So this is one example of one of my research in the health sector. Then environmental area, like Paris Agreement and emission reduction, there we use a lot of climate models, and challenges which face is a political resistance, uncertainties related to these models. And it's the main thing which we would like to do in our studies, scientific studies, that how to delineate the uh, large models to the local levels, because such climate models which we use is very difficult to use in a very specific area, and that to be in India or any one part of the world. So reducing that uncertainty was the biggest challenge, and the case which I will present where we have tried this thing, and I will take that in detail. Then comes the food security area, and GM crops and other thing. Risk assessment studies, genetical studies, these are the scientific basis, or these are the studies which we use. And public perception, scientific debates on that, what is important, food security is important, or livelihood is important. So all these discussions and debates are very important when we are dealing with policy outcome of our scientific data. Similarly, environmental protection, like endangered species and protection, when we talk about that, biodiversity studies, ecological models we use. In that, the policy related challenges which we face is funding, implementation, timing, and many times we are not able to complete the study because of the data has lot of uncertainties. While doing the study period only, we miss some data. And then public health campaigns, for example, the smoking cessation program, health impact studies, cohort studies we do, and behavioral change, long-term impact of that particular uh, mm, scientific data is key challenge. But all these challenges are actually we need to overcome, and only scientific database can provide a solution. Like smoking cessation program, we can only take it to the forward in the policy term that this age group is more vulnerable, or this age group should stop smoking. We can only bring it on the table by scientific evidences like health impact studies. So these are the some studies which I have picked up to tell you that it's not easy to go for evidence-based policy making. There are a lot of challenges, but there's yes, bringing science to society is the way. So we need to overcome these challenges. Then, briefly, what is science-based policy making for climate change? This is a schematic which talks about what is evidence-based policy making. When we talk about climate change, at this present moment also, we talk about global models, right? So evidence-based assessment like analyze climate data, emissions, and vulnerabilities based on models which are globally available. Then we go to stakeholders engagement, basically surveys, collection of the indicators, particularly uh, factors which are actually affecting the stakeholders. Uh, that is a very, very crucial and time consuming step of science based policy making, where stakeholders engagement is very, very important. Without that, you cannot have a policy on ground to work. So that's very, very important step. Then implementation and capacity building. If after analyzing our data and stakeholder engagement is complete, then action plan with clear objective. These are basically a step where we do beta testing, or you say pilot project testing, that it is working or not. Then monitoring and adaptive management. So progress using key indicators, whatever indicators we have used during our climate data or ecological model data and other data. Then if these indicators are correctly progressing or not, what we have predicted during the study is actually when action plan is implemented in the ground is working or not, or it is after some time is failing or not. So it is a continuous process. And then policy formulation and scenario analysis. Ultimately, we need to, once our pilot is successful, and then policy formulation and scenario analysis is being done. Different scenarios with this policy or without this policy has been created, and comparative analysis has been done. So this is one schematic how this policy, science-based policy making for climate change work. And step by step, I will take a case study of my own study, how we have used it, and I delineate in very, very simple steps. Yeah. So this is some of the climate models which we generally use in climate policy making, global models basically, which I was mentioning in the first step, evidence-based assessment, where we use climate models, and they are very coarse models. Their resolutions are very poor, but we do use their results for the adaptive policy making in climate change. Mhm. Uh, there that reducing the granularity, or you can say making the model more region specific, or converting GCM models to RCM, decrease the or increase the uncertainty and decrease the details. So that we need to face the challenges, and many scientific groups are working on that. Integrated assessment models, image, GCAM, message, REM, all these are used in global context. Um, uh, these are basically pathway based studies, and give us a good understanding that which pathways will lead us to less emissions basically. So important to for scenario building work, that's also very, very important. Then emission pathway models, these are the models which are basically derived from above two models, and assess emission reduction strategies under different scenarios. Representative concentration pathways and SSPs being used for basically giving the right kind of pathway which we need to follow, what kind of strategies, what kind of low carbon strategies, or what kind of non-motorized transport we need to adopt. All these things comes from such scenario emission pathway models. And socioeconomic and energy models, these are WEM is actually water related model, monitoring and water. GTAP, used for scenario plan for carbon pricing and policy analysis. So these are the some models which are broadly used in climate policy. But again, our challenge remains same, that these are the global models, using it for own country and using it for the very small region, how adaptive and mitigation strategies we can produce. So I'm coming to case one. With my case one, you will understand that how we have overcome these challenges of global model, and how we disintegrate our work into three different steps, so that we will achieve the policy which can be implemented on ground. So this was our first case. What this is called, the study we call mainstreaming differential vulnerability of Himalayan agriculture community to climate change. What we have done in this, basically Himalaya is a very big region. And when we see Himalaya, and there is a Tarai region, that is a base region, then there is a middle Himalayas, and there is a high altitude Himalayas. We have found that the adaptive strategies adopted in the Tarai region, middle Himalayas, and the top regions are totally different. When we done the preliminary studies, we find that these and their vulnerability is also different. Why? Because the exposure level to the high altitude people are much different than the Tarai region people. the high altitude Himalayas does not have water. They have water scarcity, and a lot of migration issues has been seen. So their vulnerabilities are totally different, and due to their vulnerabilities are different, their adaptation strategies are also different. So we have taken a agriculture community as our main stakeholders in this study, and then we have proposed to the government that one strategy for entire Himalaya region or agriculture community of Himalaya will not work. You need to have a differential adaptation strategies based on the altitude of the Himalaya, and we have proved this. Our study, like our work has proved to the government that yes, differential adaptive strategies are required because vulnerabilities are differential. So what was our problem statement? We have found out that mountain face challenges from inherent nature. So there is an inherent vulnerability in the mountain region because of, in some region the water scarcity is there, in some region rainfall is too much, in some regions the scarce snowfall due to the climate variability is being thing. Also, the agriculture is quite fragile and marginalized. Means the basic income of the household is very very less. So these are the few problem statements we have found out with the preliminary this thing. Then hotspot of the global climate change due to elevation dependent climate warming, and Himalayas is found to be the hotspot of global climate change, and that is why this becomes our study area. Then third point, that agriculture system face intrinsic bottlenecks mainly linked to terrain and greater dependence on rainfall. And all the agriculture system is dependent on rain. There is no other source of water for irrigations, not at the middle and the higher altitude Himalayas. But yes, the Rai region might have some sources. Then agriculture communities are disproportionately vulnerable. As I said, the vulnerabilities are different at different altitude, and diverse impact of climate change transcend to social, cultural, and ecological and economic sector. So these are the our prima facie research question when we started our work in Himalayas. Then we have done this causal loop analysis. This is what this figure is also from our paper, and basically we wanted to target the agriculture livelihood. Hence, we have understand the data of increase in summer temperature, decrease in rainfall. Erratic rainfall or excess rainfall or sudden excess rainfall, increase in winter temperature and decrease in snowfall. These are the four major variables which we have found out that on which the agriculture livelihood is dependent. And then we have done a causal loop analysis. Under that, we found that ultimately which factor is affecting the agriculture livelihood. And you will find that, for example, if I pick up decrease in snowfall, then frost increase and pest invasion increase, and due to that there is a negative impact on agricultural livelihood and ultimately income. And then because of that income decrease, livelihood change, there is a high migration has been seen, and climate related migration has been observed in the high altitude area. And we have seen certain villages there is no male in entire village was available, only females are available in the high altitude villages. Because of change in agricultural livelihood, all males has been migrated to the lower thing. So migration is their adaptation strategy, higher altitude one. So that was because of that. And food security is another reason that people not getting enough agriculture for even subsistence. Farming is not working on that. So hence these kind of causal loop has helped us to find out the predictor indicators and how we will work on that. So this is our entire study where we have break down the entire work into three different steps. So how we have break down the global, basically global data or global models into us for the study of the villages to the Himalayan region. And if you see, we have three steps. This is an integrated study. First step of our study was village level. So scale was village level. Second, in the second step, our scale was household level, and the third was is a farmer level. So breaking further, we have reached to that. So in the step one, we have based on census data, how many villages are there in which Tarai region, middle region, or higher altitude region. So then secondary data was our source of data. And methodological framework which we have used is a IPCC vulnerability assessment framework, which is basically the vulnerability is inversely proportional to adaptive capacity. So we use this methodological framework of IPCC to find out the first step of analysis. Then we created the vulnerability map of each village. Each village maps has been created using IPCC framework, and then we have identified the hotspots. So whatever hotspots we have able to find out, we have fed that hotspot villages for the step 2 studies. And we have done the primary survey. So primary data has been used in step 2, and they're of course time consuming, and we have not got permission, and lot of challenges our team has faced in this. Then household level, we have done household survey at the identified hotspot. Primary data household base has been collected, and here we have used the asset framework of livelihood, which is based on 5 important assets. This is UNDP asset livelihood framework. We have used that model, and then that model we have find out the farmer types and their adaptation needs based on the kind of assets they have, based of their inherent vulnerability, based of their natural endowments they have. All these things, 5 asset we have checked for each farmer, and we find out there are different kind of farmer types. Every farmer is not a farmer. There are some rich farmers, there are some poor farmers. So we have done the study at the household level, then find out the farmer types. And the third step was to do the farmer level policy analysis, where we have found that what kind of policies are already in existence in these regions, how farmer diversity take the advantage of these policies, and what are the policy gaps, so that we can help in feeding the policy gaps. So these are our publications from these studies. So the publication also comes in the series. For example, first we have found out the inherent vulnerability of agriculture community of Himalayas. Then we talk about hotspot analysis. Then we talked about indicator-based approach to assess village level social and biophysical vulnerability. And then we have worked on adaptation. So these are the series which we have come up for such study. Then gaps in current vulnerability assessment. So how our vulnerability assessment for Himalaya region was different to other. So study do not discuss the vulnerability framework in light of mountain specificity framework. So if you take out the IPCC framework of this thing, it is very generalized framework. You can apply to anyone, but we would like to create a vulnerability framework which was specific to Himalayas. Then what we have done, socio-ecological assessments we have done for each hotspot which we have identified in step 1. We have done the comprehensive socio-ecological assessments, and which helps us to find out the best of the adaptive strategies for that region. Then limited use of integrated scale approach, like integrated approach, we are saying to our studies step 1, step 2, step 3, how we have disintegrate the problem into 3 different steps and reaching to the right people. And then integrated vulnerability assessment of framework, external drivers, people and livelihood, natural system, institution and governance. So these are the so we have, by breaking our study, of course, we have taken global data sets like UNDP, Livelihood Framework, and IPCC Framework, but we have brought down to what are the local external drivers available in those villages, people and livelihood, natural system and institution governance. So this is our integrated vulnerability framework we have created. This is the first step. What we have done is understanding the inherent vulnerability. Inherent vulnerability means that that we have right now. I also have some kind of vulnerability. So focus on inner dynamics, that this is an intrinsic process. So we talked about internal factors. We are calling this intrinsic factors, inherent vulnerability. So this is the vulnerability which exists irrespective of the hazard. If climate change affects you or not affects you, but that vulnerability do exist. If you are a poor farmer, you are a poor farmer, so that your adaptive capacity is poor. If you are a rich farmer, your adaptive capacity is definitely different. So that we have captured very clearly. Then further conditions of high sensitivity and low adaptive capacity exacerbated. So if you have already have certain inherent vulnerability. These inherent vulnerability may increase if you have high sensitivity. If hazard occur after that, of course, the person who is more vulnerable will be affected more. Hence, our inherent vulnerability becomes the factor of sensitivity, and then adaptive capacity, uh, biophysical and social, both. Biophysical is like from climate perspective, and social is that inherent. So we have picked up both the factors. So this is what we have done. This study we have done at uh, carried out at village level of 15,285 villages using data collected from secondary sources. So we have done analysis of these many villages using secondary data from the census of India. And if you see this diagram, and this talks about how the vulnerability increase and decrease based on the adaptive capacity and sensitivity, but we have made it specific to Himalayas. And biophysical sensitivity, especially area exposed, hazard exposure, and then social sensitivity like population pressure, marginal population, livelihood dependency, primary dependency on rain, all these things become social sensitivity. And if we have better biophysical adaptive capacity, then definitely our vulnerability decreases. So first level of study was conducted approximately 15,000 villages. Then this is our methodology for what we have done. First, develop a conceptual framework of inherent vulnerability we have created. Then selection of indicator based on literature review, and we have find out that what important indicators we will use for the step 2. Then we have reviewed these indicators by sitting with experts of those particular areas, and then finalization of indicators for identifying the inherent vulnerability, and that come out to be a 36 indicators. Then we have done the ranking of these indicators according to importance in determining vulnerability. And here also we have worked with expert, and we have used some machine learning models. Then review of indicators ranked by experts, and then indicator weights has been determined using AHP, hierarchical method we have used, and the consistency based on statistical method, CR and CI, and then aggregation of the indicators and calculation of composite index and hotspot analysis. Moran I has been used. Then this hotspot analysis has been used, and then we have created these maps. These are called as biophysical social vulnerability maps based on the data we have used in this 15,285 villages. And if you see this two maps, one is biophysical vulnerability map, one is social vulnerability map. And the green is very low vulnerability, and the red is very high vulnerability. In some region, if you see, very contrasting results has been seen, particularly the region which are very, if you see the right side of the map, the green region, green and white patch. And if you see, biophysical vulnerability is very low. However, the social vulnerability is very high. The reason is the social vulnerability, if I say example as a population pressure, where the biophysical vulnerability is very low, generally the population concentration is very high in those villages. And because of the high population pressure, their vulnerability is high in terms of social vulnerability. Resources are not available to everyone because population pressure is there. The pressure on the resources is very high. Hence, so at some regions, we have found very contrasting result where the biophysical vulnerability is very low, but the social vulnerability is very, very high, because very obvious reason where the hazard exposure is low, then people tend to go in that region more. Then what we have done, we have found out the hotspots. Like these two maps has been merged, and then we have found out the hotspots. Though, what is our strategy? We need to focus on only those villages which are having a high social and biophysical both, right? So if you see the right side, there is a bar, their altitude zone, the lower, middle, and higher. So we have divided our maps based on altitude. So uh, the green part is more in lower, so low regions are here. more. And if you see the middle Himalayas, high vulnerability clusters are more in the middle Himalayas. And in upper, if you see, low and high are almost same, plus high-low clusters are there. So when we were working on the hotspot analysis, we have divided the villages based on the altitude. So the lower region of Himalayas, we have low clusters. So their inherent vulnerability is found to be low. This thing. So our hotspots are the high clusters which we have seen. The orange part, if you see, the middle Himalayas is our the region where we would like to focus, because our mostly hotspots are present in middle altitudes. Uh, Represent the villages that have lower capacity in resources to adapt and to change in the higher sensitivity, and they are very highly sensitive, and adaptation inherent with adaptation is poor generally. Irrigation is low in these regions and more dependence on agriculture livelihood. So our interest area, which where we have done the level 2 study, is basically the middle altitude area that becomes, which have the maximum hotspot with the high sensitivity and lower resource capacities there. So these are our few further papers on climate change perception and risk perception of the agriculture community of Himalayas, and how the agriculture land turned into liability. This is another paper which we have worked on that. And very interesting paper we have, which it's a Journal of Rural Studies, which talks about the farmers typology. I just tell you what exactly the farmers typology is. So this was our framework for understanding farmer diversity. So I told you that we have internal factors, we have external factors. So internal factors is basically coming from the our two models, IPCC model, where we have found out that what is individual inherent characteristics, and then assets: natural, social, financial, physical, and human. These are the 5 asset theory of livelihood model. So these are called as internal factors. External factors: how market is available to them or not, extension services like communication and agriculture training officers and offices are available in those villages or not, and what kind of loan based policies and banks are available for their loans and all. So external factors are basically governance factor available in the village, and above are the internal factors, this thing. Then we have found out that within the farmer community, we have farmers who are involved in livestock as well as forest produce also. So there are farmers which are not only agricultural community, but they are working in livestock and forest produce also. And then risk induced multiple stresses we have introduced in the model: erratic and decreased rainfall, decreasing snowfall, pest invasion. These are the risk induced multiple stresses we have added. And then we found out the adaptation diversity, decision to adapt, choice and adaptation option, and then differential adaptation needs we have found out. So I'm just quickly going through it. So we have internal factor, external factor, risk induced multiple stressor, and then we have found out that uh, how farmer will choose to adapt, what is his strategy to adapt. So we have found out that based on the interplay of these factors, the farmer uh, adopt differential adaptation options. So what we have done: questionnaire design and sampling. We have done the farmer questionnaires, then descriptive statistics. These are all science, right? And how science we are to come to the policy. This is one example. Clearly, the study is showing. So descriptive statistics we have used, then variable standardization and transformation we have done, and then two sequence multivariate statistics, principal component analysis and cluster analysis we have done, and then characterization of farm type clusters we have found out. So this is our result after doing that analysis. So in this result, what we have done, if you see, I just quickly take it up because it will be difficult, because I wanted to take up questions also, uh, because it is interesting to take questions then to present. Then if you see, I just take up only, there are five type of farmers we are able to find out. Basically, type 1, high resource unbound intensified crop farmers, means ki when we have done this analysis with the interplay of factors, then we find out there are 5 type of farmers. One type of farmer which are very rich, high endowed resources they have, and they are what kind of adaptation they adopt if risk comes, hazard comes, climate change affect them. They intensify crop, means high yield variety they will use. They will bring different kind of crops mixing and all. But there are farmers who are low resource endowed. They, what they do, they disengage farm laborers, means that whatever they have, because their agriculture is going to affect by the climate change. So they, what they do, they remove the farm laborers, but do more work themselves because they don't have money. And there are farmers which are medium resource endowed, so they will move to crash crops. They will change their crop type, right? So if you see, different type of farmers are using different kind of strategies to deal with the climate changes, right? Then what we have done, adaptation diversity. So our interviews and our the analysis has said that different type 1, type 2, type 3, type 4, type 5 are the farmer types, right? And the left side panel, you will see A category, B, C, D, E categories are basically different adaptation strategies. First, A is basically a crop and cropping pattern changes. B is basically livestock composition changes. C is a land use changes. D is a soil management type of changes. And if you see, I'm just taking one example, type 1. So our type 1 was high resource endowed intensified food crop farmers, wo farmers, those who have high resources and they intensify their crop. They will, what they will do, type 1, they will not adopt the uh, stop planting wheat. No, they will not do it. What they will do, they will go for the shift to millets, use high variety seeds, or change timing of crop sowing, right? So their adaptation is different than the type 2, type 3, type 4, type 5 farmers. So what I wanted to express you that if I will have one adaptation strategy or one adaptation strategy for all altitude of Himalayas, then you will miss out some of the farmers who will never get benefited by the adaptation policies which we implement in the Himalayan region. So our study is saying that there are different kind of farmers, their adaptation strategies will be different. Hence, the policy people, the policy decision makers should provide them that kind of, adaptation strategy or adaptation policy framing should be according to them, not one solution for all problems can be done. So this was our outcome, that different farmer types need different kind of uh, strategies for adaptation. So adaptation diversity, uh, for example, type 2 stepping up strategy. So we are giving the name of these strategies as stepping up. So farming forms a core activity that supports their livelihood and income. Farmers have sufficient land and labor resources, predominantly grow vegetable with intensified high yield with seeds and chemical fertilizer. So more fertilizer they will use to save your crop. But hanging strategy, if I take it up, do not opt high capital incentive agriculture. Farmer in this group seeks seasonal migration. They go for migration to lower altitude, work as daily wage labor, and borrow money. So if you see the stepping up strategy, if adopted by the farmer, they will go for high yield variety. But the hanging in strategy, they will go for migration as a strategy. So strategy is changing. And if I will give one point solution, one policy for all, then it will not work for some of the farmers. So many people will left out. So to make your policy inclusive, you need to work on the uh, needs specific strategies, and that is important, and that can only happen if you disintegrate the global models to the local adaptive strategies and adaptive maps, adaptive vulnerability studies. So key finding for our study was pervasive heterogeneity among farming household. So there is farming household have highly heterogeneous farming communities there. Farmer typology and classes are mainly determined by land, labor ratio, household size, farming preferences, alternative source of income, presence of market or not. And the customary segregation on the basis of single variables such as land size, caste, gender cannot accommodate heterogeneity, and hence multiple interaction of the variables is necessary. A continuum of adaptation strategies across farmer types is observed. Some amount of overlap do exist. This we can skip. And also we have found that these are the existing policies, and we have delineate all the policies which are related to climate change, agriculture, Himalayan region, and we found that none of the existing policy document talks about the adaptation change or adaptation and the challenges the farmers are using. Particularly for the climate change adaptation, none of the policy in these region, these are all policies which already exist, government of India policies, but they are not talking about the adaptation strategies. No mention of locally driven autonomous adaptation, no mention about the interest, obstacle, and capacities of the farmers. None of the policy talks about it. So until we will do this kind of studies for climate change, we cannot have a proper policies for the farmers of the Himalayan region. So this is the work which we have done for the Himalayan region. Quickly, I have one more case which I definitely I'm this thing missing some of the slides, but I have summarized my case one, how we have worked in vulnerability and climate adaptation. In case two, this is related to Delhi's case, and the case was transforming air quality assessment in Delhi, insights using land use regression models. So what we have done when we are doing this study, we found a good challenge that Delhi is a very big city where we have very limited number of you can say that monitoring stations which monitors the air pollution, PM10, PM2.5. Only 39 is working stations. Some are operated by central government, Central Pollution Control Board, and some are operated by the state pollution control boards. So the challenge was that using 39 uh, monitoring station, can we predict the air pollution levels of Delhi? Ideally, we assume it is not sufficient number of monitoring stations. So what we have done, this study, but when we have studied, this is again a work of my students and mine. So air quality crisis is there in Delhi region. Everybody knows about it. So we have extensive pollution impact as per exposure studies. Also, this pollution also have economic impact on GDP, gross domestic product. Uh, Cities like Delhi, we are not only one city in India which are facing the brunt of pollution, but urgency in action is required. And research direction is this: the research seeks to advance our understanding on urban air quality. So this was some of the prima facie questions which we would like to deal with, and how we deal with that. So Delhi is our study area in this. Total area of Delhi is 1500 kilometers square kilometers, sorry. And green cover is only 21%, and population density is very high. And we are, for PM 2.5 levels, we are third among the world cities, and PM 2.5 pollution rank by 2023. It's first among the capital cities, basically. But when we have done the source apportionment, and we have understood a lot of source apportionment studies of Delhi, these are in the nutshell, is the source apportionment for Delhi. Main contributor are transport, the local small scale industries, dust, and the waste burning. So these are the few very prominent sources of Delhi's air pollution. Then what is our challenge? Limited air quality monitoring coverage. As I told you that we have only 39 stations, and because of that, we cannot cover entire city. Intra-urban air quality variability means that we have a long spatial variability, and we have difference in the exposure zones. Some areas are less exposed and some are very highly exposed. And then representative monitoring stations are not enough. And it has been mentioned very clearly that at least 100 monitoring stations Delhi need to have a better prediction. Then common method which we used where to extrapolate the data having limited number of station was kriging. These are spatial based extrapolation methods and dispersion models. But what we have used land use regression model. These are the models where we have uh, used spatial information of the monitoring stations and predictor indicators like road networks, like distance of the monitoring stations to the main roads, cycling zones, pedestrian zones, green cover, all these factors we have included. And area wise, we are able to predict the air quality levels based on the land use, land cover change of that area. So these are the monitoring station distribution of Delhi. And how what we are doing, what we have done, we land use regression model is a statistical method used to estimate the spatial distribution of air pollution levels. And then pollution concentration is treated as dependent variable taken from the Central Pollution Control Board monitoring stations. And then we have created the land use regression maps and generated, and we measure individual or community level exposures. So we have done the health risk assessment based on LUR models. Uh, these land use regression models we cannot use until we have a data. So these are very important to have a data. So having a right scale data is a challenge in this thing. But land use regression model, if we have a good data, is a very good way to find out the exposure level of people, or you can say pockets of the air quality or air pollution level where um, uh, exposure studies can be done. So this is very important. So this study is becoming gradually become very cost effective pollution monitoring method based on traffic density, industrial zones, and other green cover and other predictive indicators. It reduces our reliability on the sensor based studies, and which is little costly. This also enhances special resolution of pollution monitoring. And once we create these models and these maps, they can be specific to specific area. So we can have a maps of different zones of Delhi. So one map is not enough, but zone wise map can be created. Identified hotspots based fine scale pollution hotspots based on road network traffic congestions can be made. Targeted air quality management can be given, because for policy making this is very very important. And reliable exposure assessment, we can definitely tell that this region people are more exposed to air pollutant. So crucial for epidemiological studies. And in which area we can further investigate cohort studies so that better health related and exposure level data we can find out. So this is in a nutshell, because I am running out of the time. Then these are the basically how we have used. We have collected the metrology data. We have public transport stops, gas station. Basically, these are the institutions data, POIs. We say that public institution data. Then traffic variable, road length, distance to road, building area. These all potential predictor variables we have used in our study. These are called as independent variable. The daily average air pollution concentration, annual and seasonal average concentration of 39 station, and dependent, they worked as a dependent variable. Then we have run the land use regression model, but these are all delineated at the spatial level, so latitude longitude based. So we have a spatial map we generally build. Also we have included the land cover and the population of those areas which we have chosen. How we have done, we have taken a station which is already in existence. We have taken a 2 kilometer radius buffer around that station, and all these parameter under that 2 kilometer radius buffer we have collected. And then based on that we have created a land use regression model. So this is our entire study. Then dependent variable and independent variables, simple linear regression has been run. Then filtering of the variables has been done using statistics, and then sorting of filter variable. And then addition, elimination, evaluation is being done. And certain machine learning models we have used. Um, then deep neural network, random forest classification. These are all machine learning models. And on that basis, we have created map zone wise. And based on those map, we have done the pollution exposure studies, and measurement of exposure disparity, regional socioeconomic status, and gender has been mapped. How gender is affected by this pollution, and exposure assessment we have calculated for Delhi region. So expected outcomes, improved spatial resolution. We are able to improve this resolution of our understanding. And then targeted air quality management, we can plan policy, we can give this result to policymakers so that they can plan better zone-wise laws, specific traffic management or congestion taxes imposing. Everything can be done used on based on these studies. Then reliable exposure assessment for public health and LUR model and enable us to precise estimate the human exposure, and crucial epidemiological studies and warning for the elderly people can be given. So until we have these maps, we cannot predict that way. So we have contributed to thematic areas related to NCAP also. So these are few of the references for the studies we have used, and this is all I have created for today's presentation. And now we can open for the questions for science-based policy making. And I've taken two cases to elaborate how it is helpful for us. Yeah. So, Palvi, over to you to take up the questions, please.
Thank you, Professor Kamna, for such an enthralling talk. Now I will open this session for the questions. So if anybody has the question for the speaker, you can simply on your mic and you can ask, or either you can write it in the chat and then you can ask.
Good evening, ma'am.
Yeah,
Ma'am,
please,
am I
Tulika.
audible?
Yes, you're audible,
Yeah.
Tulika.
Okay. Ma'am, my question to you is that how can we use scientific models and evidences to change the public perceptions about GMOs? And I wanted to ask that what all challenges do the scientists face when they communicate their findings to the policymakers and the public to inform evidence-based decision making?
Yeah, thank you, Tulika, and it's a very good question. So first,
Thank
I
you.
take the GMO one. Uh, See, public perception definitely will be there because that comes from different kind of, you can say, factors, and even there are certain you can say actors which are actually providing them such perceptions. So when we do studies on GMO crops, like genetically modified crops, and their results, like it will not affect your soil too much. The kind of perception is that if you once you have one kind of crop, then it will your soil will become redundant for other kind of crops. So if you will do systematic study and your results which you show is very convincing to the farmers, and you take it in their own cultural and language term. The problem generally we have seen that the science-based policy cannot percolate down to the people because the language of science is not understandable by them. So the challenge of overcoming public perception is that your results should be so simplified, uh, and this is my own experience, that whenever you do some kind of scientific research, take out some policy brief out of that. And these policy briefs are very important to change the perceptions of the locals. For example, I tell you, one of the study, which is not my study but one of our colleague was there. This is about the arsenic in the water, right? So they were checking the wells and hand pumps that there is a high level of arsenic in that. So, but people were not ready to, give up their wells and hand pumps. That they were saying, from ages we are drinking water from there. We will keep drinking the water from those wells and arsenic. But what we we have done very simple way that the hand pumps which have a high arsenic concentration, we painted them red. So whenever they go and try to fill up the water, they found that it's a red, let's leave it. So we have differentiated red and green hand pumps. So our study was saying that in the same village, there were green pumps in the red. Initially, they were not ready that we will not, stop taking the water from those pumps. But when we painted them red and green, that it is dangerous and their levels are high. So then gradually they are saying, okay, if green is available, let's not take it. So it is just an example that we change their perception by doing just a coloring. So I'm just saying that in GMO crop thing only, the challenge of this thing only, that bringing the result of your study in a such a manner that it is understandable by the people and the farmers who are using it. So that is the way you can overcome the challenge. And your second question is about how we inform um, policymakers on that. So same thing,
Yes, ma'am.
what we have do, we take out the policy briefs, UNDP, World Bank, Asian Development Banks, they have column of policy briefs. They take up, you can upload your study, create a half a page policy brief, and you can upload there. If it is good, they taken up by policy briefs of UNDP, and they are very valuable citations are there for them. So policy briefs are very, very important. Plus, you can approach the ministries also whenever you do some kind of projects also. So you can say, send. I have done myself that my studies outcome I have sent it to Secretary Environment several times through email, through post also, that these are the outcome of my study. In a very nutshell, 3 pointers. That 3 pointers. Outcomes are very simple. So in our Himalayan study, the outcome was very simple, that the at altitude adaptation policy should be there. The different farmers had different adaptive needs, and differential vulnerability for gender wise and height wise do exist. Very simple 3 term. So we have done a lot of data analysis, but the outcome is very, very simple. So send it to the ministries for which you are doing the project. But there are UNDP, World Bank, and Asian Development Bank, they do have. And now you have opinion pieces in the journals also. Now they have created a opinion pieces. So send your opinion pieces in the journals. That also is very, very important to reach to policymakers. So these are the few things which we can do. Yeah.
Thank you, ma'am.
Thanks.
Any other question? I have a question, Professor Kamna. Uh, your talk is very interesting, and it put light on, especially on the air quality. I'm very interested in that air quality in Delhi. So, as you said that with only some of the stations that are being present, that is 36 air quality station, it is not possible to uh, predict or to control the air quality. So, according to you, what are the essential, or what I can say, the cost effective and the sustainable measures, if we say, for the air pollution control in Delhi? Because we are, suffering from this air pollution problem from many decades. So, what are your suggestions, and can you put some light on this?
So, first of all, I just wanted to tell you that the study which we have done is being sponsored by Central Pollution Control Board. It is part of one project also. And this, when we have created land use regression, actually, when we started it, we didn't thought about going for land use regression models. When we have seen that land use regression model, the output maps are very high scale models, in the sense like region wise we get to that. So one thing is that they are giving us, based on land use, the road density, transport, they give us a map for that particular region, if not for entire Delhi, but only for that particular region. And within that region, where are the hotspots? Hotspots means that where the congestion is highest, where is the industrial cluster is available. So policy for that particular area can be made. Like for example, we have found in this Narela region, not Narela, Najafgarh region of Delhi, we found that the congestion is the main reason. And wherever, very interesting thing which we have found, that wherever the metro is available, there the pollution peaks has been found. Reason was this only, that around metro stations there was a lot of congestion and encroachments are there. This has not been captured by only monitoring stations, because monitoring station is one in that region. Whole west region has only one. So then in that, they're only giving the concentration in the west region is this much. But we were able to find out that in the particular area near the metro station, the pollution peak is there and exposure levels are much higher. So delineating this kind of information, or getting this information through LUR map, giving us a right kind of policy, that how we can deal with the congestion in these areas, and what kind of policy we can bring up so that congestion can be relaxed, so that air pollution can be lessened in that. So we will work on pockets, and ultimately we will achieve a larger goal to reduce the overall or improve the overall quality of Delhi. So that is important, that working on different pockets, and that can only be possible using LUR models.
Thank you so much for highlighting such a crucial point, which is, certainly been missed by many of us and some
We have
scientists.
submitted this to CPCB. Let's see how they will work on that.
Okay.
Yeah.
Any more questions?
I think there are no questions, Pallavi, so you can maybe summarize and conclude
Yeah.
this session.
Sure.